Welcome to the Microsoft Australia and OEM Teams webinar for September 2015. In this webinar, we'll be covering off a range of technologies relating to Windows Server 2016, especially some of those things that have been updated and made available in Tech Preview 3. So even though there hasn't been an announcement made yet around when Windows Server 2016 will be coming available in the channel, it's important to note that it is available now for download through the TechNet Evaluation Center, so that if you are building solutions based around Windows Server today, if you've got an interest in Hyper-V or storage technologies, for example, it's definitely worth starting to take a look at the tech preview now so that you can start thinking about how this will impact the solutions that you deploy for your customers in the future. So the four primary areas that I'll cover off will be around virtualization, storage spaces, nano server, and containers. Now, in the course of one session, we won't be able to do justice to everything in here. We'll have to go through them all at a fairly good pace. But keep an eye on the OEM team blog site, which I'll reference at the end of the recording, where we will be going through and posting up more information as it becomes available, and making sure that we take the information that is out there and make it more consumable for those of you who are more focused on the small and medium business size customers, rather than just working on an assumption that everyone out there is only dealing with enterprises. Then we'll move on to talking about some of the upcoming Microsoft events that are happening around Australia, and we'll wrap up with a link to some links to some of the main resources that you should be keeping an eye on to stay up to date with products in the OEM channel. So first up, jumping into Windows Server 2016, if we start taking a look at some of the virtualization capabilities as referenced in the last slide, probably one of the big ones that we've got now is the ability for Hyper-V to start providing host resource protection. So this means that we can start making sure that if a virtual machine starts exhibiting behavior from a memory or a processor performance or processor impact performance type scenario, all of a sudden Hyper-V can kick in and actually start taking control of that and start throttling it. And this is something that is enabled automatically, and what it's based on is some of the learnings that have been made inside of the Azure virtual machine environments. So this is a fantastic example of where Microsoft's on-premise and cloud technologies tend to have a lot of overlap when it comes to the learnings from one start getting moved into the other. So this is important because it means that if a workload, for example, does have a memory leak or something like that, and it's something that's out of context for that particular workload, we can now allow Hyper-V in Windows Server 2016 to start basically preventing it from consuming excessive hardware resources. So this is something that's an important addition because it means that you won't have these VMs that basically can sort of run away with system performance and have an impact on other things that are running on the system. Now, some of the other things that we can change with Windows Server 2016's improved version of Hyper-V is we've had things like dynamic memory support included with Hyper-V for a little while now, but the new capability that we've got here now is the new runtime resize. So now we can go through and increase or decrease the virtual machine memory without VM downtime. So this gives us a bit more flexibility, so it's one of those additional things if you think about what are the types of things you need to do with virtual machines that in the past may have required a VM restart or shutdown with Hyper-V. Things like memory or the hot adding of network adapters, for example, these are both things that are now supported inside of virtual machines. So some of the additional things here that are listed here around the dynamic memory, the runtime resize, as I mentioned, being able to go through and change this on the fly does make it a little bit more flexible. Now, I just mentioned that some of the big advancements around the virtual network adapters now is that we can go through and do hot add now. So again, this is one of those things that it's not something you need to do all that often, but when you do need to do it, sometimes you've got to wait for a particular period of time so that that you can shut a VM down without it impacting the users who are frequently accessing that. So some important things around this is that it needs to be done within Generation 2 VMs only. Now let's just spend a moment and talk about Generation 2 VMs for those of you who aren't overly familiar with Hyper-V. So Generation 2 VMs were introduced with Windows Server 2012 R2, and they're not backwards compatible with previous versions of Windows Server. But now that we're moving to a point where Windows Server 2012 R2 has been in market for a couple of years now, and there's a new version of Windows Server becoming available at some point in 2016, it's one of those things where we can sort of start working on the assumption that more and more people are using Gen 2 virtual machines in some cases. So there are some prerequisites around the OS support required here. So it needs to be 64-bit OSs with Windows versions. It needs to be fairly recent versions of Windows Client or Windows Server that do require or that can support Gen 2 VMs. So if you're trying to run a 32-bit version of Windows XP, that's not going to be able to run Gen 2 due to the OS and also due to being 32-bit, just as an example. Now, with the adding or removing of virtual network adapters, these are things that you can do directly through the Hyper-V manager, as you can see here, just using the GUI. Or alternatively, remembering this is Windows Server, so under the covers you do have a lot of Hyper-V options around this as well. So some of the things we can also start doing now, once we do start looking at moving across to the new version of Hyper-V, is we've got the ability to go through and upgrade the format that the virtual machines are using. So the configuration information moves from an XML-based system over to a binary system. So this means that it's not something you can go through easily and open up in Notepad or an XML editor to make some changes to it. It is something where you do need to either be engaging with it programmatically, or you need to be doing it through the UI. But if you do decide to go through and move a VM from Windows Server 2012 R2, for example, over to Windows Server 2016, it's not automatically going to move the VM across and upgrade it to the new format. Instead, it will keep it at the existing format until you go through and run the update VM configuration version VM name PowerShell commandlet to actually tell it to do that update. So now, once you've upgraded that VM, it means that there will be additional Hyper-V capabilities that can be supported inside of that VM. But in some cases, it's not really something that you need to rush out and do straight away. It's more a matter of when you're comfortable with it is really going to be the best time for you to do that. So in this case, you can see we've got, some of the machines that we've migrated across are still running V5 over on the right-hand side, while two of them are still already running V6. But when we go through and run that update VM configuration version, this will go through now and update the additional, we can specify to update those other two VMs over to V6 configuration information. And directly within the GUI, we can actually see very easily what configuration version the VM file is. So we don't need to dig too deep. We can see that either easily through PowerShell or directly through the Hyper-V manager tool. So after we've done that, then the next step for us is to go through and some of the new capabilities they can leverage, some of the new virtual machine drivers and integration services. What happens now is that as these get moved across to the new model, these updates actually get pushed out through Windows Update, as opposed to it being something that is pushed out through Hyper-V Manager or the ISO that you mount inside of the VMs. So this is an important change because it means that now we can start leveraging traditional infrastructure that people may already be using to start pushing out these updates. So now let's move on and talk a little bit about virtual machine servicing. So if we take a look at Windows 8.1 and Windows Server 2012 R2 first of all, this is going back to those integration services. Generally, they're updated with each new host release. So if you're moving something from 2008 to 2008 R2 to 2012 to 2012 R2, you'd want to go through and make sure that you do update the integration services as you make each of those updates to make sure you're leveraging the latest and greatest capabilities that Hyper-V is exposing. But now with Windows 10 and with the Windows Server Tech Preview, this is, as I just mentioned in the last slide, these are a few more details. This is now something that is handled directly through Windows Update. So it means that it's easier for you to go through and manage and push updates out as needed now. Another new capability that's been added into Hyper-V now is support for production checkpoints. Now, checkpoints have been included in Hyper-V since its inception, but it's always been something that's been, recommended for lab environments or dev and test type scenarios, as opposed to actually being something used in production. Now, probably the big important part of this conversation now, when we talk about production checkpoints, is the production checkpoints are always going to be created based on VMs that are in a powered off state. So even if the VM is running, the snapshot, the production checkpoint or snapshot, it's not going to bring it back where it was at that exact point in time. Instead, it will need to go through and basically run through the VM startup process, have the operating system load, and then the applications within the operating system load. So this means that it's going to be, a much happier environment when it comes back online, even if it's, there might be some portions of it that might be a little bit outdated compared to other things on the network. It will be able to go through and figure out what it needs to do to get back up to speed. So if you're using Windows-based VMs, then they just use volume snapshot service features for this. And if you are in a situation where you do have to use Linux VMs, which are, there are several flavors of Linux supported inside of Hyper-V, they'll flush the file system buffers to create this consistent checkpoint for you. So production checkpoints will be the default option now, but you can see here that you've got the ability to still switch back and do standard checkpoints. So that means that if you're in more of a lab environment and you want to bring things back up to a point in time snapshot as the VM is actually running, so that you can replicate certain things, you still do have the ability to go back to standard checkpoints, but realistically, that's really not going to be something you do too often in a production environment. So what else have we got inside of Hyper-V Manager that makes it a bit easier? So some of the important things that we've got now when it comes to connecting into additional Hyper-V servers, for example, is now we've got support built in for alternate credentials. So, for those of you who do remote administration of customer environments, being able to, get a VPN connection in and then use a single Hyper-V console to start connecting into different environments using different credentials is obviously very important. Being able to use IP addresses, doing connections via WinRM. So we've got a bit more flexibility around, the different scenarios we support, including the different types of things that may or may not be allowed to travel across the network. So what this means is that we end up having Hyper-V Manager work in a much better, much broader range of environments, rather than thinking around, we may need to establish an RDP connection into a remote server to run Hyper-V Manager. Now we should be able to start, much more seamlessly being able to do that locally. So that's just a really high-level overview of some of the changes that are coming in Hyper-V Manager and Hyper-V itself, but we'll start drilling into more details of those over the coming months in the blog series on blogs.technet.com/Oz OEM team. So let's move across now and start talking about some of the changes that are happening with storage spaces in Windows Server 2016. So first up though, a recap. So what is storage spaces? Well, it was introduced with Windows Server 2012 and enhanced with Windows Server 2012 R2. And it allows you to do things like provide, high throughput, high performance hardware at very, very low costs. So you can do things such as combining mechanical drives and solid state drives in tiered storage spaces, so that you can start caching the frequently accessed data automatically on the SSD tier, while the slower or the less frequently accessed data just gets written out or gets stored onto the mechanical drives. So effectively, the things you use frequently are incredibly fast, and the things that you don't need to use very often, you don't really notice that there's, that basically they're not running as fast as other things because they are sitting on, slower hardware behind the scenes. So important things around storage spaces is around starting to reduce costs. So eliminating complexity and starting to bring, infrastructure or capabilities that previously would have required you to go out and purchase a SAN for your customers. All of a sudden now you start getting a lot of those capabilities directly in the Windows Server operating system itself. Now, the nice thing about storage spaces is the degree to which you can scale it. So if we're talking about incredibly small scenarios versus very large scenarios, it definitely can scale up or down to meet your needs. One of the big changes that's going to be important for SMB customers as we look at Windows Server 2016 is Storage Spaces Direct. So with Storage Spaces Direct, it means that we can start having standard servers with local storage and then having the local storage start replicating amongst other local servers with local storage. So it means that we don't need to go through and necessarily invest in a shared storage solution, which has been one of the, I guess, the hurdles that some SMB customers have got, where you may be talking about a solution that involves multiple Hyper-V servers, but then when you raise that, well, we actually need an external storage device as well, it starts to make the conversation a bit more complex. Now, other things that have been improved here is, making sure that there's enhanced support for SATA devices, the newer NVMe SSD. So we're talking about devices with, incredibly high throughput NIOPS. So fantastic for running, pretty much any type of workload you want on there. So with this, it means that we can start using it in clustered environments. We can use it in scale-out file servers. We can use it to start creating our storage network fabric. But let's take a look at the different deployment choices that we've got here. So we can take a look at hyperconverged. So with hyperconverged, this is where within a single server, we have both the compute and the storage resources combined. So this is really something that targets more of the typical SMB type scenario moving forward. If we compare that to the converged or the disaggregated approach, this is where the compute and storage resources are separate. So those of you who've worked with like Windows clustering over the years and are used to having the standalone storage devices with multiple Hyper-V servers, for example, connecting into that for VHD storage, this is really that same approach, in the converged story. So in this case, the compute capabilities and the storage capabilities are managed independently. And this is something that really is designed to support very large scale out deployments. And we've got a few different scenarios here. So the images do a little bit of explaining of what's going on here. So how do we choose between shared SAS and direct attached storage options here? Well, the important thing to note first of all is that both of these will now be supported architectures in Windows Server 2016, including the current tech preview. But if we take a look at storage spaces with shared SAS, it does scale down to 2-node configurations. It supports dual parity with less hardware. But if we take a look at storage spaces direct, we've got support for whatever's inside the box for storage, anything we want to attach to the box for storage. As I mentioned, things like cheap, very cheap, high capacity SATA drives, as well as I guess more expensive but incredibly high performance NVMe devices within the hardware, within the server itself. So this gives us very simple scalability with these direct attached devices. And as you can see here, where it talks about the storage spaces direct cluster nodes, we're basically starting to get the ability to start sharing information between those. So how do we start sharing that information? Well, that comes via something called Storage Replica, and this provides protection of the data and the workloads. So we've got in environments where we do have high-speed connectivity, this is where we can start using synchronous replication. So think of synchronous replication as something that we use when, effectively within the same building, within the same office, within the same data center, for example, not something that's sitting at the other end of a high latency, slow connection. So this gives us increased resilience. So we start looking at new scenarios as well, because we can start, getting asynchronous replication taking place here as well. So it also integrates very closely with a lot of the other Microsoft storage and virtualization technologies. So it works with Hyper-V, Storage Replica, storage spaces, clustering, scale-out file server, SMB3, data deduplication, etc., etc., etc. And it's also streamlined management. So you can go through and manage this very easily through the failover cluster manager, as well as some of the upcoming enhancements to the Azure Site Recovery products. So if we take a look at the 3 key pillars that the storage team is working towards here, what we've got is replication happening. It's block level replication, not file level replication. As I mentioned, we've got synchronous and asynchronous. So synchronous if we do have high speed, low latency connectivity, and asynchronous when we do want to start pushing it over slower or make further connections, for example. We've got flexibility around how we can work with this. So, all the different types of storage solutions that Windows supports will also be supported here. And then from a management perspective, we've got, as I mentioned, failover cluster manager, Azure site manager, site recovery. We've got PowerShell options. So we've got multiple ways that we can go through and start having this replication take place. So let's work through a few different scenarios here. So we'll start with the simplest one, which is a single server replicating to itself. So what we're really doing here is just replicating the data within that server. So it may be from internal storage to externally attached storage, but still all classified as direct attached storage, for example. So in this case, it's a fairly simple one. We've got the single server, it replicates to itself. And what we can do here is we can seed data onto that other storage. In case we did then want to, for example, ship that off to another location. Now we've also got server to server. So with server to server, in this case, you can see that it's talking about two domain controllers. They're in the same state. They're both in. They're in adjacent states in the United States. But what we can start doing here is doing the replication. And really, it's going to depend on the latency, etc., that will determine whether we can do this synchronously or asynchronously. But at this point, we're probably, they're not in the same data center, so we're probably already at the point where we are going to be, considering doing this asynchronously rather than synchronously. So the next step is, moving away from a server-to-server scenario and to a more advanced scenario, which is doing the replication from cluster to cluster. So what we've got here are two separate clusters in separate locations again. And in this case, what we'd need to do is, if we needed to do a manual failover, we could do that. But once again, we've got flexibility. If these were clusters within the same data center, it would be easy for us to go through and set these up as for synchronous replication. But in the scenario here where they are in different cities, it's probably going to be a better idea to do it via asynchronous synchronization. Now, the final one is when we start looking at doing a stretch cluster. So with this scenario, it's a single cluster stretched over a large environment, and we've got it set up for automatic failover. And in this case, we need to use synchronous to make sure that everything is in sync. So for a stretch cluster to work, we have to make sure that we've got high speed, low latency, highly available connectivity between the two different data centers that we've got listed here. But again, it's a scenario that is supported. So some of the important things to note here. So first of all, that it is synchronizing based on blocks, not on the files. It's not the distributed file system replication capabilities that have been in Windows for a while. This is a new technology. And this is really something that's been built up based on some of the customer requirements when they started using storage spaces and some of the other capabilities that Microsoft provided in Server 2012 and 2012 R2. The customer said, well, look, the next logical thing is that you need to start providing some of the same capabilities that SAN vendors are providing when it comes to this kind of data replication. So we've got replication of the storage blocks underneath the clustered shared volume file system, NTFS or REFS. And it doesn't matter if the files are in use. So, it could be open files or locked files. That doesn't matter because it's working at the block level. So the important thing here is that, from a performance perspective, the important thing here is it's really the right IOs that are what matters to the storage replica. So how do we decide whether to go with synchronous or asynchronous? So if we take a look at the synchronous requirements, we're talking about network latency of less than a 5 millisecond round trip. So, in this case, it's saying assuming the light speed vacuum is ideal, 5 milliseconds is around 1500 kilometers round. So the reality is that optical fiber is going to reduce this. There are switches, routers, firewalls, etc. And for most situations, though, for customers, there are going to be financial limits as well as the availability of these types of solutions. So the end result is, for most scenarios in most locations globally, you're generally talking about a 30 to 50 kilometer maximum area. So ignoring latency, what about network bandwidth? Well, again, we're talking about something where we do expect high amounts of bandwidth. So we need to have, greater than, equal to or greater than a gigabit network connectivity. And you'll see here that it's between servers. That's a starting point. So it's really saying that this is really the minimum you should be looking at. So how much more than that will you need? Well, it really depends on how much you're going to be pushing across. So this is something where you need to think about the amount of traffic that that you are going to be working with here. So the important thing here is looking at how you can start trying to translate the IOPS of your workload translate to actual network usage. And then finally, for the log volume, performance and size, perhaps, investing in, storage that will handle this effectively. So looking at flash type scenarios based on traditional SSDs or NVMe. And here, if you do have larger logs, it means that you've got faster recovery from larger outages. But, if we are talking about using SSDs and NVMe storage for this, okay, there is going to be an associated cost with that. So what about asynchronous? What are the recommendations here? So first of all, for the network latency, okay, it doesn't matter. I know that it sort of sounds like a big comment, but it's not that's the reason why we've gone asynchronous, because we are working on the assumption that the bandwidth's not fantastic. What about network bandwidth? Well, it's as much or as little as you need, and it depends on your right I/O. And the log performance and size, well, that's basically the same as what we saw on the previous slide. So making sure that you've got enough speed and capacity to be able to, recover in a fast manner, rather than being, having the appropriate investments in networking, but then finding out that your disk subsystem just doesn't support that. Okay. So what are some of the other enhancements that we've got inside of the storage subsystem in Windows Server 2016? Well, one of the other areas that's had enhancements made is in the data deduplication capabilities. So if we take a look at Windows Server 2012 R2, one of the things here that you'll find is that they've gone through and made some big changes around the volume sizing recommendations. So with Server 2012 R2, they generally would have recommended keeping the different volumes that you're deduping to below 8 to 10 terabytes, and if needed, creating multiple ones on a single storage device. So that way you could go through, and when the data dedupe jobs kick in, it means you can have, you'd have a single job per volume. So you could actually have multiple jobs running at the same time on the same volume. Whereas if everything was just on one larger disk or one larger volume, you've only got that one job running. So it's going to take a lot longer for that initial task to run, and it's also going to take longer for each run to take place. Now, if we take a look at the Windows Server 2016 changes here, important things here is that it basically says use the size you need, up to 64 terabytes per volume. So for most organizations, they're probably going to be fairly safe with 64 terabytes per volume. There are going to be people who do need multiples of that, but for most organizations, a 64 terabyte volume really isn't a restriction at this point in time. So other optimizations we've got here that really help to allow this to perform better when we do start doing the deduplication is, it's multi-threaded per volume, so the files are optimized in parallel. So instead of breaking things up into multiple volumes, we can keep it as a single volume and benefit from the dedupe working across a larger range of data and potentially saving us a lot more space. So we start getting new capabilities such as the auto load balancing of the input queues and resources to make sure that overall we just do get much better performance from the storage subsystem here. So that's not it though. There are additional capabilities that have been added in. So we've got probably some of the important things here. Probably the big one here is that with the Nano server that we'll talk about shortly, this does have support for the data dedupe capabilities built in as well. So that's an important one, but we'll get to that one soon. So let's move on. And using that previous slide as the lead-in, let's talk about Nano server and how we got to Nano server. So the story so far is, if we go back to Windows NT to Server 2003, we basically had the the core Windows, and then we could add additional roles and features to that. So no real surprises with that. But as we move to Server 2008 and Server 2008 R2, this is where we were introduced to Server Core and the full server, where we could go through and start adding in additional roles over the top of what it was we installed by default. But then with Server 2012 and 2012 R2, things were enhanced even further. So we started seeing the ability to use Server Core. Then we had the minimal server interface, which gave us just enough of the GUI to run the management tools such as Server Manager, any of the DHCP or DNS type tools that you needed as well. And then we had the full-blown GUI shell. So if you just wanted full Windows with Windows Media, with Internet Explorer, etc., that's what the GUI shell would give you. But again, each of those options did have the additional components or roles and features that you could add on top. So the next step is, if we take a look at Nano Server, it's a new headless server, it's 64-bit only, and it's a new deployment option that we've got now for Windows Server that sits below Server Core. So it's really all about taking a lot of the learnings that they had from Azure in terms of what really needs to be running inside of Windows Server to keep things running. But it's also important because it ties into some of the things we'll talk about in the next module, which is around virtual machines and containers. So how do we start working with things like the containerization options provided by Hyper-V and Docker in Windows Server 2016? So it means that we end up with something with a much smaller footprint. And if we take a look at it, the roles and the features live outside of Nano Server. So there's a limited number of things you can do with a Nano Server. So if someone says, I want to make it a domain controller, or I want to make it this or that, these aren't roles that Nano Server will actually support. And we'll talk about some of these as we go through. Now, we've got standalone packages that install like applications. So basically we can run them. We can do it locally through PowerShell, or we could use remote management tools to do the management as well. It's got full support for Windows drivers, and it's also got the Microsoft Windows Defender anti-malware capabilities built in as well. So what are the roles and features that Nano Server includes? So we talk about it having a zero footprint model. So the server and the roles and optional features, they live outside of Nano Server itself. So those standalone packages, as I mentioned, they install like applications. So what's Nano Server designed to run? Well, it's designed to run Hyper-V, it's designed to run storage, so things like scale-out file servers. It's designed to run in clustering type environments. It's got Core CLR, ASP.NET, designed to be used in platform as a service type scenarios where you don't need full-blown Windows installation, just a portion of the Windows capabilities to allow applications to run. And it's got full Windows driver support, as I mentioned, as well as the anti-malware support built in. So if we take a look now at how you get started with this, we'll just run through a few different screenshots here to let you see what's included with this. It's an installation option, but you don't choose this option during setup by just booting off the ISO. So you need to go through and you need to customize it with the appropriate drivers, and the installation source files are located on the Windows Server ISO files. And it is currently available within the Windows Server Technical Preview. So how do we add the drivers, roles, and features? Well, here inside of the Nano Servers folder, you can see we've got the compute package, the failover cluster package, the guest package, OEM drivers, storage package, and the reverse forwarders package. And the tool that we use to start adding these in is we just use DISM. Now, this is a recording that's targeting OEM resellers. So those of you who've been building images for a while should be familiar with the DISM command. So in this case, we're just using DISM, add driver, driver path, or add package. So for those of you who have been using, the ADK or Windows, AIK or the OPK over the years, this is something that's going to be very, very familiar to you. So, the learning curve is going to be very small. So other things that you'll benefit from if you have been using those tools is The customizations take place by using an unattended XML file placed in the Nano server folder. And if you take a look at the unattended XML file, this is something where we've been working with unattended XML files with Windows for many, many years now. So back in the XP days, we're talking about unattend.txt. Now we're talking about unattend.xml from the Vista timeframe onwards. So these are things that are great for those of you who have already been using some of these capabilities, inside of previous versions of Windows for deployment purposes. And it's, I guess it's one of those benefits of it, being a Windows installation. Even though it's a new thing called, Nano server, we can still leverage a lot of the existing skills we've got to deploy it and to manage it. So moving on then to, we've covered deployment. What about, how do we actually manage this? Well, we've already mentioned that it's not, it's a headless experience. So it's not designed for you to sit at a console and really, interact with it directly. So how do you do remote management? Well, I won't go through all of the options here because you'll see that, we'd spend an hour or two going through them all. So I'll just focus on some of the top ones, but we've got, the graphical and web tools. So we can use Server Manager, for example, probably one of the most obvious ones. We've got PowerShell capabilities. We've got, Hyper-V Manager. We've got deployment and monitoring. So we saw DISM. And then we'll also have partners that work alongside Microsoft to make sure that the different tools that you're using out there to deploy and manage things on top of Windows Server today continue to work. So why would you want to consider using Nano Server? So let's take a look here at a few different scenarios. So if we take a look at this as it builds, if we take a look at the number of important bulletins, so this is analysis based on patches released in 2014. So what percentage of these would have needed to have been applied to Nano Server versus Server Core versus full server? So if we take a look at this, Nano Server, you can see here, is always going to be substantially lower because the install footprint is much lower, which means the attack surface is lower. So probably the important one here, I guess that really sums it up, is if we take a look at the reboots required. Nano Server sits at 3, then we double that to go to Server Core. Then if we take a look at full server, we're almost, basically we'd need to be, restarting the full server once a month. So basically Patch Tuesday every month, we would need to go through and do a full server. Server Core, we could skip every second month, and Nano Server, basically it's something that we could schedule for once per quarter. So moving on from servicing improvements onto the security improvements, let's take a look at some of the things here. So first of all, in terms of, I guess this really starts to explain, the smaller footprint means, less of an attack surface. So we've got 73 drivers loaded versus 98 in Server Core. And remember, Server Core has already got a reduced number versus what you get in the GUI version of Windows. 22 services running versus 46, and 12 open ports versus 31. So all of a sudden you can start, already start doing the maths here to see that there are going to be some big improvements here overall in terms of the, just the security and the reliability that you get out of the product right out of the gate. Now, as we move on to the resource utilization, this is another important one here, because if people really start talking about scaling and they want to get as many VMs running at once, for example, this is where we can start taking a look at some of these things where, Server Core is already, once again, drastically lower than what we get with Server GUI. But you can see here that the process count is lower. The amount of disk traffic for boot is, just over half, and the kernel memory in use is just under half of what you get from Server Core. So again, you're starting to get something that's going to be much, much more efficient. Now, the final one that we'll talk about now is deployment improvements. Now, this one's probably not going to make as big a deal, on a day-to-day basis for you as you're doing your jobs, because you're not going to be setting them up over and over and over again. But if we take a look at this, Nano Server has got a 40-second setup time versus Server Core. The disk footprint is 400 meg versus almost 5 gig for Server Core. And, Server Core, again, is substantially smaller than the GUI server. And the VHD size is, again, 0.4 gig versus 6.3 gig for server core. So you can see here that there are really some huge benefits right across the board, but you have to sort of just pick and choose the types of workloads that you're going to place on it. So as the base for running Hyper-V, well, when we were out on the Roadshow earlier this year, this was one of the things that we had some conversations around, especially those of you who had already started looking at or were deploying server core. There was a learning curve. You needed to figure out what the remote management options were. So a lot of that knowledge is directly going to translate over to the Nano server as well. So let's now move on to, I guess, one of the other things that people will be, looking at Nano server for, which is starting to leverage some of the new containers technology that's really starting to pick up in the market now. So with containers, this is really all about taking workloads and starting to isolate them even further. So if we take a look at a physical installation to start off with, okay, this is something that, we don't see it too often these days, but in some places it does still happen, where effectively a single OS is loaded and a single application is loaded on a server. That was the way a lot of things did work for many years. And from there, we've moved into more of a virtual approach where we've got, higher consolidation. We can start rolling out VMs much faster, but it's one of those things where there are some scenarios where, there are still improvements that can be made over the top of this, depending on the application and the workload. So finally, we can start looking at leveraging containers. So with containers, this is really all about rolling out applications that are isolated from each other very, very quickly. So we can get better server consolidation. We can package these apps up. We run them within containers so that we start getting things like greater portability than we may have had in the past. Now this is quite a big and complex topic, so what we're about to cover in the next few slides won't really do it justice. But again, stay tuned to the OEM team blog site, and we'll start having a lot more information flowing through on that shortly. So why would you want to consider working with containers for customers? Well, the thing that's probably going to drive this is when the applications that you use start becoming available as a containerized option. So it's not necessarily something that's going to happen overnight. If for larger organizations who do their own development, it might be something that they're looking at really closely and they want to move across to this as quickly as possible. But if you are reliant on other people developing your applications for your customers, you've really got to wait for them to start getting some of these things in place. So why do developers like this? It means that they can create these write once, run anywhere apps. You can deploy them on-prem, you can deploy them in the cloud, and you start getting a much higher degree of abstraction than what you could do just through like standard virtualization solutions. Now for operations, what's good about this is we can leverage a lot of the familiar IT options that we've been using in the past, and we can start going through and deploying these. We can increase density, get better utilization. We can scale up, we can scale down much more easily. So overall, it means that we start getting some different types of solutions. But again, remember, we are going to be dependent on our, our software vendors supplying applications this way to us. So with containers, these, as I mentioned, they're isolated runtime environments for the hosted applications, and they've all got their own dependencies. So it might be the different services or libraries that they use. It might be, they need certain CPU, memory, and storage requirements. But then when we take a look at the virtualization piece, the container engine, it's a lightweight virtualization mechanism which isolates these on a per application basis by packaging them into containers. So this is something where if we want to compare this against Hyper-V or another virtualization solution, where we're virtualizing the entire operating system, there is overhead there because each of those virtual instances has got a complete OS loaded in it. When we start talking about some of these containerized options, the containers have only got what is needed for those applications to run, and then they can leverage the shared information that the host operating system can then provide to them. So that's where we can start getting some of this higher density from. So the shared OS or the shared host OS, so in this case, it runs as an isolated process, and basically it starts sharing the kernel with other containers. And one of the other things that starts happening here is that you'll find that the way that the different containerization approaches are taking is, they're all built to be very secure and, potentially incredibly isolated from each other if needed. So just because it's two apps running on the same server or two containers running on the same server, okay, it doesn't mean that they can necessarily talk to each other. And that's one of the things that really also starts adding to the benefits that are provided here. And then from the flexibility perspective, we can get abstraction from the underlying operating system and infrastructure. So we do start moving towards more of a deploy anywhere type approach. And then finally, when it comes to speed, we can really easily add additional containers. We don't need to worry about if anything in that container is going to conflict with something else that's running in another container on that VM, on that server. So it means that we can really start, mixing and matching things much more effectively on consolidated hardware, rather than thinking, as much about, well, hang on, we've got this application installed, therefore we can't install that application on that same particular VM or hardware. So how do containers differ from VMs? Well, I've touched upon this lightly, so let's just jump in a little bit more detail now. So the differences here is that each virtualized app includes the application itself, the binaries that are required, as well as the guest OS. So this is the case with a VM. So that guest OS, if we think about each instance of Windows Server, even Windows Server Core, if each of those is taking 6 gig, for example, that's a lot of storage that's being used if we've got 10 or 20 or more VMs running on a single piece of hardware. Okay, they've all got an independent OS. Sometimes this can be a good thing because it means we can mix and match different versions of Windows Server to run different workloads. But if they're all running the same version of Windows Server, again, we've got a lot of duplication of effort and resources taking place here. We've got flexibility here with virtual machines, so we can migrate them to other hosts very easily to start balancing resources without downtime. And we also do still get very high levels of security for the different workloads. So where would you perhaps want to consider using containers? Well, as I mentioned a few times already, it's probably not a decision you really need to make yet. It's something that over time you'll see that the different vendors that you work with will start providing containerized versions of some of their key applications. But where they start making sense to really start investigating straight away are for scenarios where you're talking about distributed environments, where you're talking about large amounts of scale out of a particular application or instance of that application. And if you talk about hosting scenarios, multi-tenancy, etc., these are other scenarios where they really do start making sense. So with this, we'll just sort of call it a day there on the Windows Server 2016 piece. So this is really just a really quick look, and you'll find that there's a lot more information that's coming through. So I definitely suggest you go and you grab the evaluation editions of Windows Server 2016. You've got the Hyper-V one you can download. You've got the Data Center Edition, you've got Essentials, depending on what type of customers you're going to be working with. So there's plenty to grab and download and start investigating some of these different technologies. So let's move on now and talk about some of the upcoming events. So probably the big one on Microsoft Australia's calendar for the year is the Ignite event. So this is a major 4-day event on the Gold Coast. So obviously not everyone can take 4 days off work and go along to this event. But obviously if it's something where you've got staff that you really need to get trained or up to date on a broad range of Microsoft technologies, that's probably one of the best places to send them. Now, there are some other training courses taking place as well. So there's 3-day Windows 10 deep dive training events taking place in Sydney, Melbourne and Brisbane in September. So just to sort of point out, if you take a look at Melbourne and Brisbane, they are on the same dates, but they've got different people delivering them. So it's not a typo. They're trying to get this first round of training done before the end of September. Now, other training events that are coming up are a continuation of updated versions of the Modern Biz technical training series for SMB resellers. So the 4 ones that have been confirmed so far are Connect with Customers, which is all about basically using data to work with your customers to make sure they can better communicate with their customers. Safeguard your business about locking down your customer environments. grow efficiently around leveraging different technologies to give customers different solutions. So maybe looking at where do cloud or hybrid solutions enhance the current on-prem scenarios. With Business Anywhere, this is about leveraging the different remote technologies Microsoft has to make sure that customers can be productive anywhere. And there's also a Windows 10 one-day event coming up. The details of that are to be confirmed. So as soon as those do become available, we will post them up on the Oz OEM team blog site. So on to other resources now. Well, I guess the big one from Microsoft Australia's perspective is Smart HQ. So this is where you've got a lot of different types of sales, marketing, and technical information on a range of Microsoft OEM products up there. You'll see, offers from Microsoft, offers from the different distributors, offers from the different OEMs. So there's always something new going up on that site. There's the more technical focused Microsoft Australia OEM team blog site. So this is primarily focused on Windows Server and Windows 10 from an SMB customer perspective. So even though occasionally, it may dive into deeper technologies or different technologies, primarily it's, targeting those who target the SMB channel. And then we also do have the OEM Server AU at Microsoft.com pre-sales email alias for Microsoft OEM server products. So if you need assistance with OEM server product licensing or scenarios, for example, shoot an email through and we'll get a response back to you fairly quickly. So that brings us to the end of the presentation. So I'd like to thank you for the time that you spent on the call with us today. We do appreciate that, and join us again next month for the latest news.